3 is asking us to use a truth table to assess these values. So I think what I'm going to start with is just creating the truth table, and actually I'm going to create the truth table for both the statement and the converse so that we can evaluate what's going on here. Okay, so you should do this with me as I'm doing this. P, Q, and then here's the statement, if P, then Q. And then the converse, I hope you remember this, the converse is just if Q, then P. All right, so let's just create these scenarios here. So to make sure we have all of our combinations here, true, true, false, false, and then we can have true and true, true and false, false and true, and false and false. Okay, so if you recall, if the only way that a conditional statement is true, the only way that a conditional statement is false is if the hypothesis is true and the conclusion is false. So this one is false. That means all of these are considered true. All right. So now we are interested in the if Q then P statement, right? So we're interested in the converse. So that means we need to look at the Q, if Q then P. So the only way that if Q then P is false is if Q is true and P is false. So let's find the place where Q is true. Here Q is true and P is false. So this is where the converse is false. Otherwise, they are all true. Okay? I hope that makes sense for all of you. Basically, what we did is we're looking at the Q value. Remember that if the hypothesis is true and the conclusion is false, that's when the overall truth value of the statement is false. So let's find the hypothesis Q. Here the hypothesis Q is true, the conclusion is false, therefore the entire statement is false. Otherwise, the truth value, it has a truth value of true. Okay, so which is true? The statement if P then Q, its converse, both, or neither. So let's start out with this. P is true and Q is not true. That's what we've been given. So P is true, Q is not true. So automatically we're directed to look at this row right here. So in a case like this, look at this if P then Q, right? Okay, so that one is false, all right? So this is false. Is the converse true? When P is true and Q is not true, when P is Q and true is false, then is the converse true? And you can see here the answer is yes. So it says use the truth table to answer. We've done that. So which is true? The converse is true. And the way that we know that is using this line of the truth table right here. Now, the last question is, if a biconditional is formed from the statement and its converse, is the biconditional true? Well, let me remind you that with a biconditional, the only way that a biconditional is true is if the statement, and let me just make sure I have that right here. The only way that a biconditional can work is if P then Q is true and Q then P is true, right? Okay, so biconditional is if P then Q is true, and then also if Q then P is true. Well, these are not both true, not both true, okay? And you can see that from looking at this row right here, okay? They don't have the same truth value, okay? So therefore, the biconditional cannot be true. All right, so you could say no, based on what you can see here, because the original wasn't true. You could say because the statement if P then Q wasn't true. Okay, and that we got from looking at this right here. If P then Q was not true. All right, I hope that makes sense for you.